Hi, this video is part of a series of videos on student misconceptions regarding ratios and proportions. In this video, we will address a misconception in which students think that a fraction representation gets inverted when we represent it as a ratio. Let us see a sample question on this. This question states that in a school, the number of teachers is equal to 2/7 of the number of students. What is the ratio of the number of teachers to the number of students in the school? The options are A. 2:7, B. 7:2, and C. Need to know exact number of teachers and students to say anything. What does the response data show us? We can see that out of 3,312 students of grade 6 who attempted this question, a large percentage got it right and chose option A. However, a strong percentage of students also chose option B instead of C. Why is this? Let us look at another question of a higher difficulty level. In this question, it is given that the ratio of the number of bats Shyam has to the number of balls that he has is 1:5. Which of the following is true? Option A, the number of balls Shyam has is 1/5 of the number of bats he has. Option B, the number of bats Shyam has is 1/5 of the number of balls he has. Option C, the number of balls Shyam has is 5 less than the number of bats. Option D, the number of bats Shyam has is 5 less than the number of balls he has. The data on this question tells us that out of 5,788 students, 44% are choosing the correct option, which is B, but around 32% students chose option A, which is the opposite of option B. Why does this misconception occur? This misconception occurs because of the lack of understanding of what the ratio actually represents. In the previous question, as the ratio between Shyam's bats to Shyam's balls was 1:5, the student thought of this in fraction form as the number of balls being 1/5 of the number of bats. Some of this might be attributed to an error on the student's part, or in the case of the second question, incorrect reading of the word statements. Let us see some ways for us to remediate the misconception. We must clearly illustrate how quantities in fraction form can be compared as ratios, as we are comparing parts of quantities to each other. We can also represent objects and quantities visually to help in clearer understanding of the question. For example, if you have a question like this: in a class, the number of boys is equal to 2/3 of the number of students. What is the ratio of the number of boys to total students? To solve this question, we can take the denominator of the fraction as the number of students. We can visually represent this and then take 2/3 of the visually represented quantity as the number of boys. To find the ratio of boys to students, we can simply take the visually represented number of boys and then compare it to the total number of students as shown before. This way, it will be easy for a student to see how we compare quantities with fractional parts. However, we must not let students make the mistake of comparing parts to a whole in all cases. This is another prevalent misconception which occurs in fraction ratio problems. For example, in a question like this, 2/3 of the students in a class are boys. What is the ratio of boys to girls in the class? Students might answer 2:3 in this case. We must make clear the distinction between comparing parts or subsets and wholes, which is the denominator of a fraction. So in this video, we talked about the misconception dealing with fraction and ratio representations. I hope you found this video useful and informative. Thanks for watching.